Hello, Red Devil Nation. It is time for properties of rhombi, or rhombus, as we say in the singular world. Rhombi is plural, rhombus. Oops. Rhombus is singular. Okay, so a rhombus is another special type of parallelogram. Now, I want to review just a little bit. Remember that we talked about parallelograms kind of being the granddaddy of the quadrilaterals. Parallelograms, and we remember that there were several things that were true about parallelograms. We remember that they had opposite sides, parallel. We remember that they had opposite sides, congruent. We remember that opposite angles were congruent, and we remember that adjacent angles, or those partner angles, were supplementary or added to equal 180 degrees. And the last thing that we remembered was that diagonals bisect each other. Then from parallelograms, we then talked about rectangles and squares. And we remember that a rectangle is a special type of parallelogram where it has 4 90-degree angles, 4 right angles, and that the diagonals are congruent to each other. And that was the only change from a parallelogram to a rectangle. And then we talked about how a square is a special type of rectangle where all 4 sides are congruent. All right, so now we're going to talk about a rhombus. And a rhombus is a special kind of parallelogram over here. And the only thing that is new and interesting about a rhombus is that all 4 sides are equal. All 4 sides are congruent. So it has opposite sides that are parallel. It has opposite sides congruent. It has opposite angles congruent. It has adjacent angles that add to be 180 degrees, and it has diagonals that bisect each other. And then adding to that, it has that all 4 sides are congruent and the diagonals are perpendicular, just like squares. Now, the funny thing is that a square is also a special type of rhombus, okay? So if you see a square, it's not only a square, it's also a rectangle, it's also a rhombus, and it's also a parallelogram. But today, we're going to focus just on this rhombus over here. Well, and then we're going to talk about kites, but right now, just a rhombus, all right? So let's go and let's talk about that rhombus. Okay. So I'm going to mark this picture up. This is what a rhombus looks like. And let's talk about what those properties might look like on a rhombus. So this first thing that it says here is that opposite sides are congruent. Now, in math talk, we know that that looks like these 2 tick marks on the sides. So we know that those 2 sides are equal because they're opposite, and these 2 sides are equal because they're opposite. All right? And then in math talk, we also know that opposite sides are parallel, and we know that the math symbols for that are those little arrows on the lines. So we know that this side is parallel to that side. We know that this side is parallel to that side. And that's what gives us those zigzag angles in the middle that are congruent. And we'll talk about that in a second. And then we also see here that opposite angles are congruent. And we know in math talk that opposite angles congruent means that this angle right here is equal to that angle, and this angle right here is equal to that angle. Opposite angles are congruent. And then math talk also tells us that consecutive angles are supplementary. And we know that consecutive angles are supplementary mean that these 2 angles add to be 180. These 2 angles add to be 180. These 2 angles add to be 180. And these 2 angles add to be 180. We know all of that as well. And then the last thing that this tells us is that diagonals bisect each other. And we know, because we've already dealt with this before, that that means if I draw this diagonal here and this diagonal here, that means that this piece is going to be equal to this piece, and that this piece is going to be equal to that piece. So that's what all of those things mean. Now, then we have 3 additional properties here that go along with rhombi. And the first is that all 4 sides are congruent. All 4 sides are congruent, okay? So that means that this side is equal to this side, is equal to this side, is equal to this side, just like with a square, okay? The next thing that is new to a rhombus is that those diagonals are perpendicular. And we know that diagonals being perpendicular means that there's a right angle right there, that all 4, 1, 2, 3, 4, all 4 of those angles in the middle of that rhombus are right angles. And the last thing that's kind of cool about a rhombus is that the diagonals bisect the corner angles. I'm going to call those vertex angles. Okay, and what that means is, you're going to look at this in yellow highlighter here. What that means is that it cuts this angle in half, it cuts this angle in half, cuts this angle in half, and it cuts this angle in half. So that means that this angle right here is equal to that little angle right there, and so forth and so on. So those are our properties of a rhombus. Now, let's take that and let's apply it to 1 and 2 here. All right, number 1 tells us that JK is 12. All right, JK is 12 and JN is 7. Now, before I even look at what it's asking me for over here, I'm going to mark up this rhombus just a little bit. I know, because I'm smart, that if this side is 12, oh, it said JN, not JM. Silly Weber, silly Weber. My bad. JN is right here, that's 7. I apologize. Okay, again, I know, since I'm smart, which is kind of disputed now, but it's fine, that if this side is 12 and this is a rhombus, then that means that all 4 sides are equal, which means if that side is 12, this side has to be 12, this side has to be 12, and this side has to be 12. I also know, because I'm smart, that the diagonals are bisected, which means if this piece right here is 7, this piece over here has to be 7 as well. Other than that, I don't have any other information about this rhombus, so let's see if we figured everything out. The first thing it asks us for is JM, and JM is this piece right here. And we know, we can see that that is 12. All right, JL. JL is the whole diagonal right here from J to L. Now, I know that both of those pieces are 7, and since I'm smart, I know that 7 plus 7 is, you guessed it, 14. The next thing it asks us for is MN. All right, let's take a look at MN. MN is this piece right here, but we don't have that piece. But we do know that these diagonals right here make a right angle, which means that that is a right triangle, where N is right here, J is right here, and M is right here. And I know that JN is 7. I know that JM is 12. And I'm looking for MN. So I can use my Pythagorean theorem. And I know that MN is going to be my little a. So I'm going to have a squared plus 7 squared equals 12 squared, which is going to be a squared plus 49 equals 144. When I subtract that away, I get 144 minus 49, and I get that a squared is equal to, what is 144 minus 49? Briley, what's 144 minus 49?
It's negative 5.
Or 95? Could it be 95?
That's plus.
I said minus. 144 minus 49.
That's negative 5.
144 minus 49.
I thought you said,
44 minus 49? It's 95. And then we take the square root of 95, and we get that A is equal to 9.7. And we'll go to 1 decimal place here. 9.7. Awesome. All right, the last thing it asks us for is MK. MK is this whole diagonal right here. Well, we just figured out that this part of the diagonal is 9.7. And that means that this part of the diagonal has to be 9.7 as well. And we know that 9.7 plus 9.7 is 19.4. Do you understand how to do number 1? Excellent. Let's move on to number 2. I'm channeling my inner Dora the Explorer here. All right. The first part of this says that EF is 23 and DF is 40. That's that whole diagonal in there. All right. Now, we know that if DF, that whole thing is 40, that means that each half of that has to be 20 apiece. We also know that if this side of the rhombus is 23, all of the rest of the sides of the rhombus have to be 23 as well. All right, so let's take a look at what we have to figure out. The first thing we have to figure out is GF. GF is this piece right here, and we just said that since that's the side of the rhombus, it's going to be 23. Now we have to figure out HF. HF is right here, and we already figured out, since that was half of that diagonal, that was going to be 20. Now we got to figure out GH. Again, we have a right triangle situation here. All right, so we'll call GH our little a, and then we'll have a squared plus 20 squared equals 23 squared. So a squared plus 400 equals, I don't remember what 23 squared is off the top of my head. I'm going to go look. Oh, 23 squared. 529. And then that means that a squared is 129. And we take the square root, and a is equal to 11.4. 1 decimal place here. All right, so GH is 11.4. And we know that if that part of the diagonal is 11.4, then this part of the diagonal has to be 11.4 too. So GE, which is that whole diagonal piece right there, is going to be 11.4 plus 11.4, which is 22.8. Okay, I hope you've enjoyed these notes.